Welcome to The Explainer. Today, we're diving into a project that honestly feels like it's straight out of science fiction, building a powerful, custom AI assistant that lives right on your own computer. I mean, just imagine this for a second. You find a long 2-hour lecture on YouTube. You drop the link into an app on your PC, and not only do you get a perfect summary, but you can actually chat with it, ask it specific questions. And the AI that's answering you, it's running completely on your machine, using only the information from that video. It's like having a personal research assistant who becomes an instant expert on demand. Okay, so let's get into how we actually build this thing. The first step, like with any good project, is to gather our tools. We're setting up our digital workshop. Now, the most important tool in our entire kit is Langchain. Seriously, if our whole project is a car, Langchain is the chassis that everything else gets bolted onto. It's basically a framework that lets us connect all the different pieces, the AI model, our data, our user interface, and makes them all talk to each other so they can work as a single, powerful application. Okay, so our toolkit is really like a specialized team of libraries. We've got Gradio to whip up a simple web interface, and YouTube transcript API to, grab the transcript. But the real stars of the show, the ones that make this whole local setup possible, are Ollama, which lets us run an amazing model like Llama 3 right on our PC, and FAISS, a super fast search library from Meta AI. We'll see why that speed is so critical in just a minute. So, with our tools all laid out, the first real job is to turn a YouTube video, just a stream of pixels and sound, into raw data that our AI can actually understand and work with. And this whole process is surprisingly simple. It really just happens in 3 stages. First, we just need to grab the unique ID from the video's URL. Easy enough. Second, we use that ID to fetch the entire transcript. But here's the catch. We can't just throw a giant wall of text at the AI. So that third step is absolutely crucial. We have to intelligently break that transcript up into smaller, much more digestible chunks. So that first part is really straightforward. We have a simple function that uses our YouTube transcript API library. It just takes a URL, finds the video's unique ID, and pulls down every single word of the English transcript. And just like that, boom, we have our raw material. Now, why do we need this chunk transcript function? Well, you can think of large language models as having a kind of short-term memory, which we call a context window. You can't just give them an entire book to read at once. They'll forget the beginning by the time they get to the end. So this function, using something called a recursive character text splitter, breaks that long text into smaller pieces, maybe 1,000 characters each. And here's the really clever part. It makes the chunks overlap a little bit. That way, we don't accidentally cut a sentence or a complete thought right in half, which is so important for keeping the original meaning intact. All right, we've got our data prepped and ready to go. Now we get to the really fun part, actually crafting the AI's brain. This is where we take all that text and give our model the power to understand it. What's really interesting here is that our bot actually uses 2 different kinds of AI working together. On one side, you have the big, large language model, the LLM. In this case, we're using Llama 3. This is the thinker. It's incredible at reasoning, understanding complex language, and generating answers that sound human. Then, on the other side, you have an embedding model. This is the translator. Its only job is to turn words and sentences into a list of numbers, a vector, in a way that concepts that are similar end up with similar numbers. So, what do we do with all these number vectors that our translator created? We feed them into this function, create FAISS index. You can think of FAISS as a super fast digital librarian. It takes all of the numbered vectors from our transcript chunks and organizes them into a special, highly efficient database called an index. This is what lets us search through the entire video's content almost instantly to find exactly what we're looking for. And how we use that index is the real secret sauce here. It's a technique called retrieval augmented generation, or RAG. The best way to think about it is like giving the AI an open book test. When you ask a question, we don't just ask the AI. First, we use our FAST index to retrieve the most relevant chunks of text from the video. Then, we hand those chunks to the LLM and say, okay, answer this question, but you are only allowed to use the facts from this text I'm giving you. This is amazing because it forces the AI to stick to the facts from the video and stops it from just making things up.
All right, so the backend is ready. We have our data pipeline, we have the AI brain, but how do we as humans actually interact with it? Let's connect it all to a user interface.
And this is where that Gradio library comes in to save the day. It's honestly so simple. With just a few lines of code, starting with this little phrase, with Gradio.blocks as interface, we can build a really clean and simple web UI. This code creates all the pieces we need, the text boxes, the buttons, the output fields, that act as the front door to our entire application. And right here, this is the magic wire. This single line of code, process btn.click, is what connects that pretty user interface directly to the powerful engine we just built. It tells the app, hey, when a user clicks the process video button, I want you to run the entire workflow we just built. One click kicks off that whole chain reaction. Get the transcript, chunk it up, summarize it, and build that searchable index. It's just so elegant. Okay, so we've clicked the button, the video's processed, we've got our summary sitting there. What happens next when the user actually types in a question and asks for an answer? Well, it all comes back to that brilliant RAG technique we talked about. When you type your question and hit ask, the answer question function kicks in. It takes your question, turns it into a vector, and then zips over to the FAISS index to find the text chunks that are the closest mathematical match. It grabs those chunks, the most relevant context from the video, and hands them to the Llama 3 model to generate a really precise answer based only on that open book information. Look, building a cool bot is one thing, but the fact that this whole thing runs locally is the real game changer. Let's just zoom out for a second and talk about why this is such a big deal. The benefits here are huge. First, and this is a big one, privacy. The video you're analyzing, your questions, none of it ever leaves your machine. It's not sent to some company's server. Second, you're in complete control. You're not relying on some third-party API that could change or shut down. You don't even need an internet connection after you've downloaded the model. It's also modular. If a better model comes out tomorrow, you can just swap it in. And all of this leads to an incredible conclusion. Powerful, cutting-edge AI isn't just for giant corporations anymore. It's for everyone. At the end of the day, this project is so much more than just a YouTube summarizer. It's a blueprint. It's proof that the tools to build custom, private, and seriously powerful AI assistants are now, finally, in our hands. So the real question isn't just about what this one bot can do. It's about what happens next. What will you build?